Hash file organization and hash indexing. In this particular lecture, we will study the different kinds of possible structuring in hash file, uh, and based upon the concept of hash, we can build hash indexing for our database also. So let's guess what is the hashing. So suppose we have list of items. So we can ask several questions at the beginning, that how to know the location of any data item. Suppose in the data list we want to search any item. So how can we get the exact location of the item? And the next question is, what is the fastest way? Usually to search item we search element by element or binary search. But how to search directly that item, whether it is possible, whether it is there or not. Also, another question asks that can you generate some address so that I can directly go to the particular location of the item. So this kind of question can be answered using the concept of hashing. If you consider the structure of an array, what we do naturally, that we have set of elements like this, okay, and we have corresponding index location for each element. So whenever we want to create an element, we provide the index entry. Suppose we are trying to fetch any item at the location 4. So we'll get, after reading, suppose the name of this array is A. So if I provide this information, this will give us 98. Okay. So we can see that in this particular concept of array, that providing an index value or providing an address, we can directly access the element. But one problem is that to access this element, we have to know, and before that, what is the location of this element. There's no way we can get the idea that if I try to find item 98 in the list or not. So we cannot get this idea before that whether this element has the location 4. There's no way. So from this basic preliminary idea of direct addressing from the array, we can build a system in which we can actually get an idea of the address of a particular item. So in this diagram, in this picture, we can see that there are few elements 36, 18, 72, 43 and 6, and we have a collection of slot to hold some elements, particularly these elements, and the length of this total storage is 8. Okay, so next thing, we have to generate address from this element. So we divide it and take the remainder. So 36 will give the remainder 4, 18 remainder 2, something like that. So whenever we get a particular remainder, we go to particular location and we insert that element. So the next time when we want to search any element, suppose 72, we'll divide by 8 and we'll get the remainder 0. So we go to the first location and retrieve the data item. So you can see the accessing of any particular item is very fast, faster than array also. So what is the computing time is the constant time order of 1. That is the advantage of using hashing. So having this basic preliminary idea of hashing, we can build a storage structure for larger database also, or any particular file. What we do in case of storing records for the database. So first, memory blocks are provided. Okay, usually called it bucket, to store the records. So in each bucket we will store, each bucket we will keep records. Right. So the next question is how to find a particular bucket to store the record. So in this case we have to take help of a hash function. So there may be different way. In the previous example we have taken modulus operation as a function, but in other cases we can take any types of hash function we can think of. So arbitrarily think that h is a function and we have to pass the key. In the previous case key was the different number 36, 72, something like that. So here is the key. We have to pass the key. We can divide it by 8 and we can generate a particular address. So here the key is 36, but in other case key will be different. So after passing this key, that will generate a bucket address. Okay, suppose we have different buckets. Okay, this is 0, 1, 2. So whenever key is provided, suppose the key generates bucket address 0. So the record will be stored in the bucket 0. If in another case for any particular key, if it generates bucket number 1, then record will be stored in the bucket number 1. Okay. Similarly, in particular different case, we have different key value address and the particular bucket will be selected. So in doing so, whenever in this case the bucket size is fixed. So you can think of buckets are divided into slots. Okay, each bucket. So whenever data are filled and again some search key generates bucket number 2, then what will happen? How we can store that particular record? So for that, in this mechanism, what is being done here, that another bucket is provided and this bucket is linked with this bucket. We call this bucket is overflow bucket. So the particular event when we are trying to insert the particular bucket and we see that the size is bucket is full, it is called overflow, and for that we need to assign another bucket, and for this bucket the bucket address is 2 also. So whenever this bucket also full, we have to add another bucket, and this bucket also refer to this bucket number 2, and this whole chain of this overflow bucket is called overflow chain. Okay, come to this particular example. So this is the initial, this is my initial bucket state. So bucket 0 is full, bucket 1 is full, bucket 2 is one place is empty. So now we want to save this record. This record consists ID name, this is department, and this particular is salary. Okay, for any relation, maybe employee relation. Now if my hash function is modulus and number of bucket is 3, so what will be the bucket address for this ID? And if I are using this is our key, so I have to divide it by 3 and we are getting 1, so we are going to 1. So now you can see that bucket number 1 is full, so we have to create another bucket for this bucket address and we call it bucket overflow and insert that record in this overflow bucket. So in this way, when another record come and generate same address, we have to create another bucket here and link it. So for any record we have to do something like that, and we have to repeat these things if repeatedly every key value generates bucket address 1. So that will create a overflow bucket chain. So how to get, now question is how to get the number of buckets. So we have to select the number of records in the file and we have to decide what should be the bucket size. In this particular the bucket size is 2. So if number of records 10 and bucket size 2, so for that case we will need 5 buckets. And for hashing, we can select key any attribute, id, name, department, or salary. For different key value, we will get different layout of different records in different buckets. So this is the basic idea of how we can organize file in hashing technique. This is another example. You can see there are 8 buckets, and different entries are there for different buckets. So in this particular case, department name is the key, so we have kept same department value in same bucket. So you can see that not every bucket is used, some of the buckets are empty. So this thing happens in kind of package. So this totally the technique is called the static hashing, and this empty bucket is the problem in case of static hashing. So having this idea of static hashing, we can create a static hash indexing. So what we just go back to the example, what we have done, that in this case particularly we have kept the record inside the buckets. So in case of indexing, we don't need to keep the record in the bucket. What we do here, we keep the id value, the search id value in the buckets, and the other entry will contain the actual physical address of the record. Okay, so using the static hashing, we can, whenever we try to search, we generate the bucket address, and in the bucket address we search for the key. When you find the key, we can directly go following this physical location to the exact record. So this is the idea of static hash indexing. But in static hash indexing, there are set of problems, and that problem is solved by another technique called dynamic hashing. So what is the problem with static hashing? The size of the file has to be known before the buckets are created, because we have to know the number of record in the file, just because example, and size of the bucket, so that we can have the idea that how many buckets we need for a particular file. There is a problem. Another problem, fixed number of bucket number fixed, but database file can grow over the period of time. So when it grows, that we need to add another bucket, another few more buckets. So that is the problem with static package. Another problem that we have seen this particular example, that only few of the buckets they are being used and other buckets are empty. So what can happen, that whenever try to use buckets to store record, some buckets will get more empty than others. Maybe some buckets will be overflown, and for that we need to create overflow bucket. But what you can see, there are some space, but we cannot use because our address generation scheme, the hash function, generating this bucket again and again. So that is the problem with static hashing. So what we can do in dynamic hashing, that we can create or delete record, what we can grow or shrink according to the file size. When we are having more and more records in the file, we can create additional buckets. And when we don't have data or deleting data, so where our file may get reduced, then we can delete these unnecessary buckets. So the adjustment of these bucket numbers is very flexible. So since we are actually adding or deleting buckets according to our requirement or demand, so there is less probability that we are having some buckets which are not used at all. So this gives us the idea that we can use the resources better way. So what we actually do in dynamic hashing, we create another entry called bucket address table. What we do in the bucket address table, that it holds the address of the buckets. Now how we can index this bucket address table? Okay, because we have to go a particular bucket address from this table. So what we do is indexing is done from binary level. So the indexing can vary from 0 to 2 to the power b. So b start from 0 and goes to some maximum limit. In particular case, mostly it is 32. But we don't create all the entries on the between these ranges, which start with b value 0. When b value is 0, we have only one entry in the bucket table. That is the size of the bucket address table will like that for b equal to 0. And as we keep on inserting new records, so it will demand more space, so more bucket will be created, and our bucket address bits will grow from 0 to 1 to 2. So these are number of bits. 0 means only 2 to the power 0, only one slot is needed. For 2 to the power 1 we need 2 slot. 2 to the power 2 we need 4 slot for bucket address table. So having more slot means more numbers of buckets are being created. So go to some example. Suppose in the instructor table we want to insert record using dynamic hashing technique. So in this case we have to generate this hash address in binary format. So initially our bucket is 0. So in this case what we see here, we start with the most significant bit, these bits. Okay, this is called hash prefix. These prefixes are important to identify which record will go to which bucket. So initially 2 to the power 0 we need 0 numbers of bits, so only one slot is available. So in this case indexing may be 0. So for indexing we need only one bit, that is 0. So start with 0. So whenever any entry related to biology department or electric engineering department or music department, we can insert in these entries. Suppose we initially entered these two data. Now we want to insert this data. What will happen? We need 2 bit, 0 and 1. Okay. So now we can look the computer science. For computer science we have prefix that 1, and for finance we have 1. So for index 1 we are creating in a bucket this, and for music the initial address is 0, so we are having an entry here. So this address will indicate this bucket, this address will indicate this bucket, depending upon this bit of the prefixes. Okay. Now after that, if we want to insert another record of physics department, what we have to do? So we have, so physics department prefix is, for physics prefix is 1, but this bucket size is 2, so we cannot insert in this bucket the new entry. So what we have to do, we have to add another bucket. So if I add another bucket, that means we have to address 3 bucket. So address 3 buckets, any address 3 value, we need 2 bits. That is, b value should be b value should be 2. So the indexing will range from 0 0 0 1 1 0 1 1. Okay. So in this the picture we can see that the physics. So now we have to see the first 2 bit, first MSB 2 bits consider. Okay. Previous case we were considering only first bit. Now since we are increasing number of bit, we have to consider 2 bits here. So for physics, what is the first 2 bit? 1 0. For physics, this is 1 0. So indexing 0 0 0 1 1 0 1 1. So for physics, I have to get a bucket for this. Okay. So now for finance, what is the first 2 bit? 1 0. So they have same. So they will be put to the same record, same bucket. Okay, these two records. Now what will happen to the computer science? Now computer science to the first 2 bits 1 1. So we have to create another bucket and put the record from here to this bucket. From here, from here to this bucket. Okay. So we need some rearrangement when we insert and we have more bucket than previous one. We have to rearrange the record also, so that indexing of each record or each bucket become uniform. Okay. So after inserting physics, this bucket will hold these two entry. Computer science go to this bucket, and music will be the first bucket, because the first 2 bit of music is 0 0. So this will indicate to 0. Now what is we are doing, where we can address these 2 bit to same address, because we need only 1 bit to this kind of thing. Okay, so only 1 bit is sufficient to insert all this record inside it, but for these two blocks we need these bits. So that's why you are writing here b equals to 1 is enough, here b equals to 2, here b equals to 2. So that's why you are writing 1 2 2. Similarly, if we want to add another record, for which we need to take first 3 bits, then we have to again create a address table which whose size will be 8. So similarly, we have to rearrange all these records according to their first 3 bits. Having this idea of dynamic hashing, we can create dynamic hash index as similar as we have done for static hash indexing. So in case of dynamic hashing, what you have to do, in case of storing this record directly here, we will keep only 2 records, the search key and the address of what? Address of actual record. So all this will indicate to the actual physical address, whatever the scheme we are using. This is my bucket address table. These are indicating this one, and this will indicate to these records. So this is the way we can create dynamic hash index for the DBMS. Thank you.